Hey guys, welcome back. This is video P4, the second part of our section 4 video, and this one is about how to solve quadratic equations. And there are going to be 4 methods for solving quadratics that we're going to look at in this lesson. You've had all of these before, but let's look at these together and just look at an example of each. The 4 methods that we're going to look at are factoring, which is generally the first method that everyone learns. Extracting square roots, which again can give you a quick way to get your answers. And as we go into our standardized testing, we're looking for the quickest way to work these problems. Completing the square, which is no one's favorite, but is very useful, particularly as we study conics. And finally, the old standby, the quadratic formula. I can hear you all singing that in the back of your head right now. So let's look at an example of each of these. First, let's look at an example of a problem that you could solve by factoring. Now, factoring is the first method for solving quadratic equations. It goes back to Algebra 1. Most of you remember factoring often in that 9th grade year. Basically, this is called a trinomial. It has 1, 2, 3 parts. And it's factored by taking the first term, which is the second degree term, and it is a perfect square, so we'll write the 2 factors of it. Then we skip the middle term and go to the the third term, which is an 8, and what we want are the factors of 8 that have a difference of 2. Now the factors of 8 are 1 and 8, and 2 and 4. So we're going to go with 2 and 4. And then we are going to fix these terms, the outer and the inner terms, so that they equal -2. So if we make the 4 negative and the 2 positive, -4x, positive 2x would give us -2x. That would also give us a -8. So this is the factored version of this quadratic equation. Now, you remember to solve, you take each factor, x plus 2, set it equal to 0, and x minus 4, set it equal to 0. And you've done this so much, you know that the signs are always opposite. So x is equal to -2, and x is equal to positive 4. Now what those are, these are called the roots, or the solutions, or these are also the places where this would cross the x-axis. So if you saw a graph of this quadratic equation, all the graphs of quadratics are parabolas, so you would actually see this one cross at -2 and see it cross at 1, 2, 3, 4, and it would look something like this. That's just a quick sketch. Okay, so this is factoring, and certainly this would be a method that we would shoot for if we could factor easily. Now the problem is it's not always easy to tell how to factor something. So we have some other options, and I want to look at those with you now. The second method that we're going to look at is called extracting square roots. And let's talk about where extracting square roots makes a lot of sense. If the variable is on one side and is part of what we call a perfect square. You see how this expression x minus 12 is all squared. And the other side has what we call a constant, a plain ordinary number. In that case, extracting square roots makes a lot of sense. What we want to do is we want to get the variable on one side. It's part of a square root of a perfect square. And we want to just take the square root of both sides. So I'm going to draw a big radical here. And then if I do that on the left, I've got to do it on the right. Now, here's a trick. X minus 12, the quantity squared, when you take the square root, that's just going to give you x minus 12. Okay, that's the easy part. Equals. Now here's the trick. Plus or minus. You must have 2 answers to every quadratic equation. So if you take the square root of this, you're going to get x minus 12. But if you take the square root of this, you're going to get plus or minus. The square root of 18, 9 times 2, out pops a 3, 2 stays under. And then you don't want to just leave your answer x minus 12. You want to solve for x. So what we're going to do is we're going to bring the 12 over and say 12 plus or minus 3 square root of 2. Now, if that looks sort of like something you've seen before, think about the quadratic formula. X is equal to negative b plus or minus, and you know the rest of it. There's the plus or minus. Many quadratic functions take the form of two answers like this, plus or minus. And this is an extracting square roots problem where we can take the square root of a perfect square, get what's under the radical, and then we take a plus or minus square root of the constant. You will see many examples or many times to use this method, and again, it's a big time saver. I'm going to show you more at the end if we have time. Let's move on though to our other two methods. Here is completing the square. I'm going to cover up the bottom and then we'll go to it. Now, completing the square is probably the hardest of our three methods. And most of you are sitting there going, well, you don't have to complete the square there. That one will factor. Yes, it will factor, but I'm going to go ahead and demonstrate completing the square with this easy example. Here's how it works. To complete the square, you are going to copy the second degree term and the first degree term. You are going to take this constant term right here, and you're going to move it to the other side. Now, you can remember this by just saying, we're going to take the x term and the x squared term. The x's get to play on one side, but the number that doesn't have the x, you're going to banish to the other side of the equation. So this is what we've got so far. Now, we are going to finish or complete the square. And here's what we're going to do. We're going to make this side a perfect square. We do that by saying half of 2 is 1, squared is plus 1. And if you'll hold on just a minute, I'm going to get a red marker so that I can make this show up a little bit better. So this is completing the square. You're going to take half of this term, half of 2 is 1. You're going to square it, which is plus 1. And if you add it to the left, you're going to have to add it to the right. Now that's the completing the square part. Now, then you're going to factor this, which is going to be square root of the first, square root of the last, sine of the middle, squared. Okay, you see what you did? You forced that side to be a perfect square. And on the other side, you're going to get a 4. Now, then you're going to return to the method we just talked about, the extraction of square roots. Take the square root of this side, you're going to get x minus 1. Take the square root of this side, you're going to get plus or minus 2. And so our answer would be 1 plus or minus the square root of 4, which is 2, 1 plus or minus 2. And that means our two answers are x equals 1 plus 2, which is 3, or x equals 1 minus 2, which is negative 1. Now, the reason I picked this very simple example is because you can also have solved this one by factoring. Now, you need to remember with completing the square, the coefficient right here of x has got to be, of x squared has got to be 1. So this is not a very handy method if you, say, have a 4x squared or a 5x squared, because you're going to have to go through and divide before you complete the square, and sometimes it gets kind of nasty. All right, and then finally, if you can't factor, if you can't extract square roots, if you can't complete the square, or if you just don't want to do any of those, welcome to the real reason we're here, the quadratic formula. Now look at this particular quadratic equation. First of all, you notice, and most of you would want to, remove a 4 from everything. Divide the whole equation through by 4. And it would look like this. Divide by 4, and you will get x squared minus x minus 1 equals 0. Okay, now you don't have to do that, but most of us like to work with smaller numbers, so that works great. But it will not factor. It will not, well, you could complete the square, but it's kind of unhandy and nobody likes to do that. It does not have a perfect square on one side, so extracting square roots is out. So we have a great candidate here for the quadratic formula. Now the form of a quadratic is ax squared plus bx plus c equals 0. And let me write the quadratic formula right here. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And I know you know how to sing that little jingle. So in this problem, we are going to fill in that formula. A is equal to 1, B is equal to negative 1, and C is equal to negative 1. I get this from this equation right here. There's your 1, negative 1, negative 1. So x is equal to 1 plus or minus the square root of 1 minus 4 times AC is negative 1 all over 2a, which is 2. X is equal to 1 plus minus square root 5 over 2. And I would accept that as an answer. That's fine. Sometimes you will need to simplify. This one will not simplify, so you can stop right there. Now, one of the things you're going to need to do as you practice your equations in your textbook is you're going to need to be able to decide which is the quickest, easiest method to solve. So your choices again are factoring, extracting square roots, completing the square, or using the quadratic formula. And the only one of these that will always work, that can always be counted on, is the quadratic formula. Now tomorrow in class you will be working on a series of quadratic equations. Some will be you will be asked to use a particular method, and then others you will be able to choose the best method. This is solving quadratic equations. I expect you to be familiar with all 4 methods, and I'll see you in class tomorrow. Thank you.